So can you please tell me about the background of the study and what we know already?
So we know that you can use genetic information to try and predict various different diseases and traits. So you can take the genetic map that's come from big genetic studies and you can apply that to an individual and ask what is their risk of developing the disease. And that's been done for MS. We've done that for MS and we've shown that it works reasonably well. The problem is that we also know when you take the genetic map from studies of people of European ancestry and you apply it to people from other ancestral backgrounds, those maps tend to do really badly. And so we asked whether that was true for multiple sclerosis. So we took the big genetic map from large European study of MS genetics and we applied it to a really big cohort of people from South Asian backgrounds to see how well we could predict whether or not they had MS.
Okay, and what were the results, and what do the results mean for the future of MS research going ahead?
So we found that the genetic risk score, which came from European ancestry studies, did okay in the South Asian cohort. It did better than chance, and that tells us that there is some overlap in the genetic architecture of risk, but it did a lot worse than in European ancestry individuals. So we compared it with UK Biobank, where there are lots of white individuals of European ancestry, and we found that the score was much less good in the South Asian ancestry population compared with that European ancestry population. So that tells us that the genetics of MS risk is overlapping between ancestries, but it is a little bit different. And just using that genetic map is going to underperform if you try and predict who's going to get MS in other populations.
Okay, and are there any limitations to this study? Anything that means that we have to do a bit more looking into it?
Definitely. So even though the cohort was really big, 50,000 people, actually only 40 or so people had MS in the genes and health cohort. So that's a limitation. And that means that when we're trying to predict how well that genetic risk score did, actually there's a lot of uncertainty in that estimate, because if there were 50 people or 60 people, that estimate may change quite a lot. So what we don't know is how much of our results are just due to that small sample size and the uncertainty of the estimates, and how much is due to genuine differences in the genetics between populations.